Okay, so we are doing the course. So go ahead and say it again. What did you say about your dad?
Huh?
What did you say about your dad? Go ahead and say it again. I'm recording.
I said I don't have to eat school lunch today.
No, that's not what you said, but good change.
I'm going to my dad's room for lunch because he's getting pizza for his yearbook class.
Oh, okay. All right. Okay, so let's review real quickly the sine and the A, B, C, and D. Then we'll just do the cosine today.
Is this a new lecture? Should we keep it under lecture 25?
This is a continuing level lesson 25. Yep. So this is actually the last part of it because we're just applying it to cosine. So we have this function here, which should already be in your notes. Y equals A times the sine of bracket B times the quantity X minus C plus D. What did the A, I don't want to say do, because when I say what did the D do, that sounds bad. So what does the A, how does it change it? Yes. And it does one other thing.
It can be a reflection.
Okay, so it tells you about the amplitude, and it also tells you about the reflection. Outstanding. Okay, let's go in the order that we did them in. D. What does the D do?
D is midline.
Midline.
Translation.
It is the vertical shift. It changes the midline. Okay, very good. And then I think we talked about the C next.
Yep.
What does the C do? Somebody else?
The horizontal shift.
Horizontal shift. That tells you if it goes, whoops, I put HZ, shouldn't put HS. Tells if you go left or right. And then, of course, Savannah, your last. What does the B tell us? There's a name for it.
Phase shift.
It's the phase shift. It is the horizontal compression or horizontal stretch. Outstanding. Now, when we look at the cosine one, they stand for exactly the same thing. No difference. The way you find them is exactly the same. When you graph it is where the change comes in. Okay? We'll do the cosine parent function in just a minute. But if you think about the sine, we always started at the midline, right? We call it 0, but it also just simply means the midline. So when we graphed my sine curve, I always started here. Okay? And then I went to the max, back to the 0, down to the min, and back to 0. So 0, max, 0, min, 0. Right? With cosine, we have the same order of items, but we just started in a different place. Okay? With the cosine, I'm going to start at the maximum. Okay? Then I'm going to go to the 0, then I'm going to go to the minimum, then back to 0, and then ending at the max. So it's going to look something like that.
We did talk about that a little bit. You told us this.
Yeah, I did mention that to you. Kind of as a laid the foundation. So that's all. It's the only difference is the order that you actually graph the points. We're going to go ahead and do everything exactly the same. Okay? So let's review. I've got 3 examples, if I can find my notes. I've got 3 examples for us to look at. One of them is going to be the parent function. The next one is going to be a couple changes, and the last one is going to be all the changes put together. Okay? We good with that? Good. Example number 1. This is going to be the parent function. If you want to put that in your notes, this is the parent. But once again, refresh my memory. What's a parent function?
It means there's no transformations applied to it.
No transformations. It's where it starts. It's right here. It's where it starts, where it begins. It's no transitions. It's just the function itself. So we're going to do the parent function of cosine of theta. And you can let that equal y if you want. Y equals cosine theta. So the parent function, once again, we're graphing this the same, but in the exact same notation. And then 1, 2, 3, -1, -2. Can anyone tell me also why have I made this graph exactly the same every time? Yes.
Because these are the trigonometric functions, so these graphs have to be with the same thing because of like the circle.
Yeah. But why didn't I do this? Why didn't I come over here and say, okay, well now I'm going to go 1, 2, 3, and I'm going to go pi over 2, and then I'm going to come over here and I'm going to go pi, and so forth. Why didn't I make it bigger? Why did I always make it exactly the same size?
So that way we can base it off of the original sine function.
So you can see how it changes. So you can see the fact that, okay, this did become smaller, this did become bigger. Okay, because I can always adjust my scale to whatever I want. But if I make it consistently the same, then you see, oh, this did shrink. Oh, this did stretch. This did move up, down, whatever. Okay? So we'll just do the same. So then, if we think about, if we go back to the cosine function, think about the unit circle. By the way, quizzes over the unit circle will begin next week. Just so you know that's coming in.
But
So
like,
we
on
get
a
we get Wednesday to review Friday's test.
No,
You're
you
giving
get the quiz on Wednesday.
right after.
It'll be just the degrees and radians. And then the following week, it'll be degrees, radians, sine, cosine, you do it twice the next week. Hopefully you'll get, and I'll take your highest grade. So once you get 100, you're done.
Oh, digital.
No.
Oh.
You'll take it once a day. And so
Oh, sorry.
it's coming up. It's kind of a surprise. Okay, so look at the unit circle. What is the cosine of 0? Right here at the y-axis, what's the cosine of 0?
2, 1.
1, because it starts at the maximum.
Mm-hmm.
Okay. What is the cosine of pi over 2?
0.
0.
And the cosine of pi?
-1.
-1. Cosine of 3 pi over 2 is back to 0. And the cosine of 2 pi is back to the max. So then we have, this is our parent function, this shape. Something, whoa, wait a second. What did I do wrong?
Yeah, what did you do wrong? I was like,
Yeah, what did I do? Look at pi. What did I do with pi?
max 0, min 0.
Yeah. What is that though?
Oh, 2.
2.
Yeah.
Oh.
Remember the amplitude has to be the same both sides?
Yeah.
And when I graphed that, I just put it, I didn't want to put it over the pi, so I put it down here. So it should be here. Right in the middle of the pi, and then back, and then back here. So it's something like, I was drawing it going, this doesn't seem right. Something like that, okay? So that's what the function looks, and if you think about if you look up here, it's right there, that's what the function shows, the parent function should look. Okay, you good? Let's
Yeah.
do an example then.
Wait, do you have any like characteristics for us other than that?
Well,
Or is
it's
it
the
just like
exact same
anything?
thing, but just shifted.
Yeah,
So there's only one characteristic of the cosine that's different from the sine.
it's even.
It is the even function, yeah. Remember, cosine is odd, so it's even. So it still has domains, all positive, negatives, all infinitive, negative. It's going to be the range is -1 to 1. It's going to be periodic. It's going to be oscillating. All those things. All those things. Good.
Were you here on Friday last week?
No.
You were? Yeah, you were. Okay. I can remember.
Okay, so let's look at an example. Let's go y equals, and let's make a couple changes to this one. Actually, let's make 3 of the 4, make all of them the complicated one. So we'll do 2 times the cosine theta minus pi over 2 plus 2. Okay? So before we start, what are the changes that have been made?
Midline moved up 2.
Midline's been moved from the x-axis to positive 2. What else? Somebody else. Yes.
It's the amplitude's going to 2.
2? Has it reflected?
No.
Nope. No negative. What else?
Moving right to pi over 2.
Moving right to pi over 2. Outstanding. So, I could probably go ahead and just start graphing it. Since we know all those changes. So pi over 2. Probably go a little bit further.
I was gonna say you could probably just make your x or your y-axis go up higher.
I think I did a little bit there.
Yeah.
I'm going to go a little further. We'll see. No, it's going to 4, so we're good. Okay, so then my midline you said is moved up 2. So here's my midline. Now it's shifted, you said right, pi over 2, correct? And remember the way we find that is theta minus pi over 2 equals 0. So theta then will equal pi. Remember on the next one that's going to come in setting it equal to 0. Yes, sir?
Shouldn't midline be moved to 3 since we're starting at 1 originally because it's cosine?
Not the midline. Midline's still 0.
Oh,
We'll start at pi.
Okay, yeah, that's starting point. Yep, that's right.
Okay, so pi over 2 is going to be my starting point. And we still have the same period, so we're still going to go to 2 pi. So at pi over 2, where do I start? I don't start at the midline, but I start where? At pi over 2, my starting point's not there
Oh, because it's still 4 because the amplitude.
because I start at the maximum, which happens to be 4. And then because we didn't really do a phase shift, this isn't compressed, this isn't stretch, I know it's going to be every pi over 2. So that means at pi, I'm going to be at 0. At 3 pi over 2, I'm going to be at, let me say that again. At pi, we're going to be at the midline, which is 2. At 3 pi over 2, I'm going to be at the minimum, 0. At 2 pi, I'm going to be back at the midline. And at 5 pi over 2, I'm going to be back to the maximum. And we can see the shape right in there. We've stretched it vertically. We've slid it over. We haven't changed the period at all. We haven't changed the phase shift. That's what it looks like. And then, of course, to be completely accurate, you should put arrows on the end. But I'm just asking you to graph one period. Questions on that one? Now, Savannah, that was kind of an easier one, right?
Right.
Why was that kind of easier? Because what? What? It was. Why was it easy? What's the one thing we didn't do to it? We didn't do a reflection. Okay, no, there's 2 things. What else did we not do to it?
Phase shift.
We didn't compress it. We didn't stretch it.
Stretch it.
We didn't do any phase shift to it. Okay, and that makes it much easier, right? Because we know it's just going to be every pi over 2. These are our key points. So, guess what we have to do?
We're going to do one for the phase shift now.
We have to do occupation shift. This will be the last one I go over. So if you have questions, now's the time to ask. So let's go ahead and reflect it too, since Savannah brought that up. It's okay, it was already in my notes. -1 times the cosine, and let's make it 2 pi minus, and let's go with, should we make this one really hard?
Yeah.
Let's make this one kind of challenging. Let's make it 2 pi over 3 plus
6, 7.
6, 7 over 3 plus, let's go with minus.
You sure did miss that, huh? Oh, you're on.
-1. There we go.
Oh.
No, I did not.
Just wrote. Come on now. I just wrote plus 1. Come on. You
I know, I
can't do
changed
it
it to
like that.
-1. Well, last one we went up, this will go down. Okay? Alright, so we have our changes, right? We know it's going to go down 1, we know it's going to be reflected. So rather than starting at the maximum, I'm going to start at the minimum. So go minimum 0, maximum 0, minimum. Okay? Then I'm going to have it shifted to the right, but we don't know how far yet. Yes.
Question. Why did you do 1 for the amplitude? That doesn't affect it at all.
It doesn't really affect it, but if I just put a negative, it looks kind of ugly, so that's why I didn't do it. Normally, if I'm typing it, I'll put a 1. You don't really have to do that. Alright, so let's go ahead. Oh, I think when we did these, I didn't do the graph first. We came over here and we did the phase shift first, correct?
Yes.
Okay. So my phase shift. How do I find the phase shift?
2 pi over b, which is
2.
So 2 pi over 2, which is going to be equal to. Okay, so explain to those on the camera, what does that mean? What does the phase shift mean?
The phase shift means so in the span of like what it usually is, like similar to your period.
So my period, going from the max, 0, min, 0, max, the whole group is going to happen inside of a pi,
Yeah.
as opposed to 2 pi.
How many period? How a fraction or how many periods happen within the main sequence?
Correct. So I'm going to shrink it down. Rather than being 2 pi, it's going to happen in pi. So I've compressed it. Okay? So is it my starting point?
No.
Is it my ending point?
No.
No. We have to figure those out. But the distance between starting and ending will be pi. All right, so number 2. How do I find the starting point?
Take what's in the parentheses inside.
Correct. I'm going to take 2 theta minus 2 pi over 3 equals 0, then I'm going to solve. This is why I did this one. It makes it a little more difficult. Because I end up with 2 theta equals 2 pi over 3
Divided by 2.
divided by 2. Now, if you think about that for just a second, if I have 2/3 and I divide it in half, how much do I have?
2/3 and you take half of it, 1/3.
It's 1/3.
Oh.
Yeah. Half of
Oh,
2/3
yeah.
is just 1/3.
Yeah. Okay.
So it's just going to be pi over 3. If you need to see the math, multiply by 1/2, because 1/2 times 2 is going to be 1. Multiply by 1/2, and the 2's will cancel out with pi over 3. Okay? So solve that fraction however you need to. Pi over 3. But do not go to decimals. Make sure you leave it as pi over 3. So now, what's pi over 3?
So
Pi 3 is our
pi
starting
60
point.
degrees.
60 degrees. What'd you say?
Our starting point.
It's my starting point. So let's go ahead and graph it. It is 60 degrees. Very good.
Thank you.
It'll come in handy on your quiz next Tuesday.
Good to know.
Ow.
Okay, I don't need to go past that because it's all going to be within that. I
Um,
know I'm going to have 1, 2, 3, 4, 5. Okay, so where's my midline?
Your midline is going to be
um,
-1.
Right down here in the middle through all of my labels. Right there. Okay. And where's my starting point going to be? It's going to start at pi over 3, which is about right here, correct? It's about right there, pretty close to pi over 2, just a little bit less. Okay, and then it's going to be at what point? Is it going to be at 0, -1, -2, -3, 1, 2, 3? What is it going to be at?
-2.
-2, because my midline is -1, and it reflects, so I'm going to start at the minimum, which is down 1. Right there. All right, you remember how we find next?
Wait, but why is that? Is our starting point?
we go to our max.
What'd you say?
Would
What'd you
it
say?
be a vertical shift? No. Why is our starting point not?
Why is my starting point not here?
No. Well, not. But just like, why is it not on the 0?
Because
That's my starting point. It's at pi over 3.
So, but
Because it's been shifted. It's been shifted there. Remember what this does. This expression shifts it to the right. So my starting point is no longer at the axis. It's shifted it to the right. Good question.
and also it's cosine, so it doesn't start on the 0.
Correct. So we start at the min or max. In this case, min because it's reflection. Okay, so that's my starting point. Now, how do I find my ending point? That's my next thing to do.
2 pi over 3.
How do I find it?
you
Oh,
have to take the phase shift subtracted by the starting point.
Correct. So I'm going to take pi over 3, and I'm going to add to it pi. Because that's the distances we're going to have, right? So I start at pi over 3, I'm going to go for a full pi. So I'm going to common denominator, pi over 3 plus 3 pi over 3. What's that going to be equal to?
2 pi over 3.
Nope.
Oh, sorry.
Add them. You add them.
4 pi over 3.
So 4 pi over 3 is going to be somewhere. Where's 4 pi over 3?
It's before. It's after pi, but it's before. Yeah.
It's in the third quadrant, right? So it's in that third section, close to 3 pi over 2. So that's going to be my minimum as well, because that's where it ends.
Okay.
Whew. What's smack dab in the middle?
The maximum.
Okay, the maximum, but what's smack dab in the middle of pi over 3 and 4 pi over 2?
2 pi over 3.
No, 3 pi over 6. No,
Is it not 2 pi over 3?
no,
Between
because
pi and 4.
it's 2 pi and 3 and 3 pi and 3.
4 pi over 3. No.
So it's 2.5 pi over 3. Which
Oh,
would
that's
equal,
really ugly.
Which would equal what?
So the way we get that is, since they're already pi over 3s, we just do 1, we just do 1 plus 4. Do you see where I got those from?
Mhm.
The 1 in front and the 4 there. Okay, and I add that together and divide by 2. Okay? The problem is I don't do 2.5 pi.
Yeah.
We don't do that. Okay? So the way you do is you simply change them.